You remember how we said that this was a 220 ohm resistor? Each band, each colour of each band, refers to a particular number. And here are the colours with their numbers. This is the resistor colour code. The first band is the first number of the resistance value. The second band is the second number of the resistance value, but the third band is a multiplier, or simply shows the number of noughts. That 220 ohm resistor is 2, 2 and 1 nought. If it was a 470 ohm resistor, then it would be yellow, violet and 1 nought again. 4, 7 and 1 0. So if we were to change that third band from a brown to, say, a red band, then that would mean it was 4, 7 and 2 zeros. 4,700 ohms, or 4.7k. This final band down here, silver or gold, just gives you the tolerance of the resistor value. Now here's a random selection of resistors. Let's have a look at them. This one, brown 1, black 0, blue is 6, so that's 10 and 6 zeros, that's 10 megohms, 10 million ohms. This one's grey, red and yellow. Grey's 8, red is 2, yellow is 4 zeros, so it's 820,000 ohms, 820k. This is a big old resistor. It's orange, red, which is 3,300 ohms, 3.3k. Next, moving on to this much smaller resistor, it's a lower power resistor. 5, 6 and black is 0, so that's 56 ohms. 5 and 6, no zeros. The same with this one. 2 for red, 7 violet, no zeros, 27 ohms. Next, this is a very low power resistor, probably 1/4 of a watt, and it's upside down. It's brown, red, which is 1, 2 and 2 zeros, 1.2 kiloohms, 1200 ohms. This is brown, black, green, so brown is 1, black is 0, and then green is 5, so there's 5 zeros, so there's 1 and 6 zeros in total, which is 1 megohm, 1 million ohms. And this one is red, yellow, which is 2, 2, and yellow is 4 zeros, so that's 220,000 ohms, 220k. Now you can see they're all different sizes. That's because they're different powers. If you're going to pass a high current through a resistor, then you need a higher power resistor to handle that current. Well, I'm sorry to say, that means there's another formula coming up. The power in a resistor is equal to the voltage across it multiplied by the current going through it. So P, the power in watts, is equal to V, the voltage in volts, multiplied by I, which is the current in amps.